Alright, so today's problem, we have a positive and a negative charge, where the first charge is charged at 5 microcoulombs and the second charge is charged at negative 3 microcoulombs. And the electric force between them is 0.72 newtons, and the question is asking us to find the distance between the charge. Now, Coulomb's law pretty much describes what we learned in chemistry. Where two opposite charges, like a positive and negative charge, attract, but two like charges, like a positive and negative, repel each other. And this equation is pretty much describing that, which says that the electric force equals K, the constant, times the absolute value of the two charges multiplied together over the distance squared. And this is similar to Newton's law of universal gravitation, where two masses are attracted together by gravity, and how the more distance there is between the two masses or the two objects or the two particles, like in Coulomb's law, the lesser the force is going to be. If we want the distance, we have to derive an equation for it. So first, I'm going to divide the electric force by both sides, and then I'm going to multiply r squared to both sides. We're going to get an equation: r squared equals k times absolute q1 times q2 over the electric force. And to get r alone, obviously we're just going to square root the sides. So our final equation for distance between the two particles is going to be r equals square root k times absolute q1 times q2 over the electric force. So plugging in our values, we're going to get 8.99 times 10 to the 9, that's the electric constant, times 5 times 10 to the negative 6 times 3 times 10 to the negative 6 over 0.72, and that's all going to be square root. We're going to get a final answer of 0.432 meters at the distance for the two particles. Next problem. A hydrogen atom has a proton, Q equals 1.6 times 10 to the negative 19 coulomb, and an electron, which has a charge of Q equals negative 1.6 times 10 to the negative 19 coulombs. The distance between the particles is 5.3 times 10 to 11 meters, and the question is asking us to find the electrostatic force of attraction between the particles. So we have to remember Coulomb's law, which states that the electrostatic force of attraction between two particles is the electric constant times the absolute value of the charges divided by the distance squared. So we can plug our values into Coulomb's law, where K, the electric constant, is 8.9 times 10 to the 9, and the absolute value of our charge, so charge 1, the proton, 1.6 times 10 to the negative 19, and our charge 2, the electron, negative 1.6 times 10 to the negative 19, and then all over the distance squared, which is 5.3 times 10 to the negative 11 meters. So multiplying our charges, we're going to get 2.5 times 10 to the negative 38, and now we're just going to multiply k into here and then divide it over 5.3 times 10 to the negative 11. So the product of the electric constant and the two charges is going to be 2.304 times 10 to the negative 28. And now we have our distance, which is 5.3 times 10 to the negative 11. We have to square that to get our final distance squared value. Squaring this number is going to give us 2.809 times 10 to the negative 21. So putting this on a calculator, our final electrostatic force of attraction is going to be 8.2 times 10 to the negative 8 newtons. And yeah, that's our answer. Thank you for watching.